time.
So,
Outstanding.
factoring quadratic expressions. This is similar to factoring numbers. The difference is that we are going to be factoring polynomial expressions, specifically quadratics, as the name of the section would imply. So we're going to have to remember how to do this sort of thing. When I ask you to factor a polynomial, what is the first thing that you should try? The first thing that you want to look for is a GCF. Now, in the problems today, most of them will not have one, but when you're asked to solve a polynomial expression, the first thing you should try and do is factor out a GCF. That is the easiest situation in which we're asked to factor a quadratic, but the reason we know that it's the easiest is because of the leading coefficient. Leading coefficient is the coefficient of the term with highest degree. So we need to remember what those words mean. The coefficient of the term of highest degree. Leading coefficient is the coefficient of the term of highest degree. This is the term of highest degree, so our leading coefficient is 1. When the leading coefficient is 1, you just want to find two numbers that multiply to 6 and add to 7. Those two numbers are positive 6 and positive 1. And that is how we factor this quadratic. Quadratics will hopefully, usually, factor as a product of two binomials. What is this expression in factored form? 4x squared minus 28x. What's the first thing we do? We look for the GCF. That's the first thing we should always try and do. And in this problem, we have a GCF of 4x, leaving me with x minus 7. And you cannot factor anymore. So when are you finished factoring? When you cannot factor anymore. We have 4x, we have x minus 7. So this is a situation where the quadratic does not factor as a product of two binomials, but that's what happens here. What is this expression in factored form? We know that this one is not going to be easy, like the first example, because the leading coefficient is not 1. In this case, the leading coefficient is what? 2. Leading coefficient is 2. So you're going to have to choose here between those two. There's a guess and check. There's a process. Let's start with the guess and check method. You know, since it's a quadratic like this, with 3 terms, it's going to factor as the product of two binomials. And you know, since the first term of the quadratic is 2x, that with these binomials, you're going to have a 2x here and an x here. So we say 2x minus 3, x plus 4, because negative 3 times 4 is negative 12. And if we FOIL this out, we would get 2x squared plus 8x minus 3x minus 12. So we have these two, we covered that already. And those middle two terms, the outside, inside part of FOIL, plus 8x minus 3x, 8x minus 3x is 5x. So this is our factored form.
I like to call it guess and hope.
Awesome possum. Now, what we do, that's not at all what I meant to put. We have the guess and check. Now we're going to go through a process. Step 1. Take the first term's coefficient of 2 and multiply it by the last term. Negative 12. We get negative 24. The second step is to look for factors of negative 24 that will add up to be 5. Those factors are 8 and negative 3. Once we have those, we use them to rewrite our original problem, 2x squared plus 5x minus 12. as 2x squared plus 8x minus 3x minus 12. We have 4 terms. We need to do a process called factor by grouping, where we take the first 2 terms, group them together, and take the second 2 and group them together, which is why it's called factor by grouping. We have one group here, one group here. In each group, this is step 4, we're factoring. In each group, take out the GCF. So in the first group, we have 2x times x plus 4. In the second group, the GCF is a minus 3. Leaves us with an x plus 4. What we have there is the same thing as 2x times some variable I will call spiral, minus 3 times spiral. Because we have x plus 4, it's the same thing, right? Spiral here, spiral there. With that, we can factor that spiral out, and it's going to be spiral times 2x minus 3. And so what this ends up being is x plus 4 times 2x minus 3, which is the same thing we got in our guess and check method. So in this problem, the leading coefficient is a 1. So all we have to do is find 2 numbers that multiply to be positive 36 and add to be negative 12, which is x minus 6, which we would prefer writing as x minus 6 squared. Since we can rewrite this as x minus 6 squared, we refer to this trinomial, because there are 3 terms, we refer to it as a perfect square trinomial. And again, the reason for that is that when we factor it, we can write it as a binomial squared. That is why we call it a perfect square trinomial. The difference of 2 squares is named the difference of 2 squares because you have to have a difference, meaning subtraction, of 2 things that are perfect squares. Give me an example of a number that is a perfect square, Mr. L. 25 is a perfect square because the square root of 25 is a whole number, 5. Is when we talk about variables, perfect squares are going to be things like x squared, because the square root of x squared is x, or x to the 4th, because the square root of x to the 4th is x squared. So for a variable to be a perfect square, we just need for it to be raised to an even power. It just needs to be divisible by 2. If we have all of that, then our formula for factoring will be a plus b times a minus b. So as a quick example, if I have x squared minus 16, how does that factor? Right, x plus 4 times x minus 4. We know that this is a squared, meaning a has to be x. This is b squared, meaning b has to be the square root of 16, which is 4. And then we do a plus b, x plus 4, times a minus b, x minus 4. When you are given something like this and asked to factor, you need to notice that there are 2 terms, and that it is subtraction. So the first thing you should do is try and do GCF factoring. Do these 2 terms have anything in common? No, nothing other than 1, which wouldn't help. So then what you need to do, since it's 2 terms and it's subtraction, we need to check and see if this is a difference of 2 perfect squares. So we need to check the square root of 81x squared, see if that's going to give us a whole number. Because we know x squared is a perfect squared because it is raised to an even exponent. And the square root of 81 is 9, so the square root of 81x squared, 9x. The square root of 100 is 10. So we know that we are subtracting two things that are perfect squares. This we will call A, this we will call B. So my original problem here is the same thing as a squared minus b squared, which is 9x squared minus 10 squared. Using our formula, we get that that is 9x plus 10 times 9x minus 10, which is our answer. So this is a fun example. X to the fourth minus 16. We want to factor this. So we have two perfect squares because for a variable, if it's to an even power, it's a perfect square. Any variable to an even power is a perfect square. So we have x to the fourth minus 16. So two perfect squares, and we are subtracting them. So it is a difference of two squares. So we have x squared plus 4 times x squared minus 4. So from here, we are not finished factoring until we cannot factor anymore. We cannot factor this, which is what you were missing. This. We cannot factor this. So in our final answer, we're going to have x squared plus 4 because we cannot factor that anymore. But x squared minus 4, two perfect squares, it is a difference. So that factors as x plus 2 times x minus 2. So our final answer, x squared plus 4 times x plus 2 times x minus 2.